Okay, good morning. Welcome to grade 10 mathematics. And as is our practice, we start off the grade 10 class by trying to look at the questions that were set for the junior secondary school exam, affording the opportunity to look back to the exam and then use that as a foundation to address the demands that on the OBJ. In Monday and Wednesday, we're going to be treating the theory. And the exam says we should answer 4 questions, but we will solve everything. We'll solve everything and we'll try to be quick about that. Okay, so we go to question 1. Question 1A. Question 1A says what? We should simplify 2a minus 3 over 2 plus a plus 4 over 2. This one is quite simple because here the LCM simply will be what? 2. The LCM is 2, and that will be 2a minus 3 plus a plus what? 4. Now, when solving this question, especially when you have used this to divide to get this, I always advise you case in a bracket first. And some people will tell you, oh, it doesn't really matter. Yes. Yeah, right. But for purpose of learning, I advise you to put the bracket there first. And then next line, expose the bracket. Now, what happens is that if you have a positive number, a positive 1 multiplying the bracket, it leaves the bracket as it is. Does not affect the content of the bracket. Now, the next thing we do is to add up, collect like terms. Books will tell you collect like terms, but more recent work I've been doing, I try to tell children, look at it and try to add up, do the collection of bracket and terms in your head. 2a and a here will give me what? 3a. And I have my negative 4 plus 3. This is interpreted as what? 4 minus 3. And that will be what? Plus 1 all over 2. Do we get that? Okay, so that takes care of that question 1A. You see that the question is a very straightforward question. Now, in question B, we are told to sketch, okay, a triangle ABC is what? Having the angle 90 degrees at B. So that invariably will tell you that this triangle is a right angle triangle. So this will be B, this will be A, and this will be C. Please take note of something. When it comes to triangles or shapes generally, we name in an orderly manner. So that you go anti-clockwise or you go clockwise, but the letters must follow orderly, right? So that's the triangle. Say draw and label a sketch. This is the triangle you're going to have. Now I say calculate the length of the third side. Calculate the length of the third side of the triangle. Now, this might be very, very difficult for you to figure out. Where is the third side? Now, the question itself is not very explicit. This is one side, this is another side. But technically speaking, when we talk of the third side, we may mean this side. So, I'm only making an assumption based on the provision of the question. So, if the third side is this one, then perhaps what they are expecting you to do is to state Pythagoras. So by Pythagoras, comma, AC squared will be equal to what? AB squared plus what? BC squared. You get it? I am the one insinuating this one now. I don't know how true that is. So which means that AC will be equal to the square root of what? AB squared plus BC squared. I have a reservation on the question, but you're in the examination hall. We don't know the marking scheme. So I think this will just suffice for B. The question is incomplete. That's my own personal opinion, though. So that's for question 1B. Now we go to question 2A. In question 2A, it says draw 3 different types of quadrilaterals and do what? So what would you draw? Here I will advise you to take very simple shapes. I'll draw the square, but your diagram will not be correct if you don't put a 90 degrees here. So I'll advise to put, once you put one here and one here, it is a square. So I'll tag it square, and then I'll draw another. Okay, maybe I should come to the other side of the board. There are so many you will draw, but having analyzed the exam, I decided to opt for the ones that will be very easy for me to handle. So this is a rhombus. And what's the last one? I opted to go for the rectangle because they said quadrilaterals. So I opted to go for a rectangle. Once I put 90 here, put 90 here, that's a rectangle. Are you seeing that? So that's the rectangle for you. So that's for question 2A. So 2B. Now what's 2B asking? It said we should do what? State two differences between any two. So any two, I could pick rhombus, and I could pick square. State what? Any two differences between a rhombus and a square. Number one, what's the difference between a rhombus and a square? All angles are equal and 90 degrees. Here, opposite angles are equal. All the angles are equal to 90 degrees, but here only the opposite angles are equal. That's one. What other thing can we take of from a rhombus? What other unique property can we take from a rhombus? Some students may want to say this parallel to whatever. It's the same thing here. In fact, a square is a special type of what? Rhombus. Another thing you should take note of here too is that all diagonals are equal. Diagonals are what? Equal. For a square, the diagonals are equal. But for the rhombus, no. Diagonals are not equal. Now, the choice could go on and on. People can take rhombus, square, and compare, but I chose to use, a student can take rhombus and rectangle to compare. But this is the one I have chosen. And I feel it will be easy for me to handle in an exam setting. All right, so that's for question 2B. Now, it says state two similarities between any two in A above. All right, it's similarities. So what are the similarities now? Similarities between any two. So 2B, similarities. Similarities. So for these similarities, I will pick any two again. Let me pick any two. Let me pick, which one do I pick now? Maybe I should pick rhombus and okay, maybe I should pick square and rectangle. Square and rectangle. Okay, another interesting thing you should take note of in a rhombus too, you can hear you have 4 lines of symmetry, 4 lines of symmetry. Here you're going to have 2 lines of what? Symmetry. You understand? So that's another key feature you could have. 2 lines of symmetry for rhombus and then 4 lines of symmetry for. So I just given you 3 differences you can see here. All right. So similarity between a square and a odd angles lines of symmetry. So those are the 2 important ones. You can have others. You can have others. I talked about lines of symmetry now. For you 1, 2, 3, 4. Yes. Oh, am I sure about that? I hope I have not made a mistake. Let's see. Oh, sorry, these both lines of symmetry. This one will not suffice. I think I've made an error there. For a rectangle, it is 2. Just this and this. So 4 lines of symmetry will not be correct, and I've cleaned that off. So number 2, what other unique property can we think of when comparing a square and a rhombus? Another important one will be diagonals bisect themselves. Diagonals bisect themselves. If we were comparing the square and the rhombus, for instance, for the square and the rhombus, if we were comparing the square and the rhombus, for instance, we would say that diagonals bisect at 90 degrees. But for a square and a rectangle, these are the major similarities between them. The diagonals will bisect, but for a square, it will be 90 degrees. But for the rhombus, for the rectangle, it will be what? Not 90 degrees, depending on the angle setup. All right, so that settles that problem. That would take care of question 2. All right, question 3. Question 3 is equally a question that is not very clear. Prepare a table of values from -2 to +2 for x minus y equal to 1. All right, I will just solve this with what I think the examiner wants you to do. All right, so we're giving the values. So when they say the tables of value, or rather the table of values, that's what's actually called. It means that x is less than or equal to what? +2, and x is greater than or equal to -2. It means x is from -2 to +2. So I would advise you first of all, now the question given to you is x minus y equal to 1. You can't do anything with this except you make y the subject of the formula. That's why you were taught change your subject formula. So this will mean that x minus 1 will be equal to y. So we rewrite this. This will be y equal to x minus 1. So this is what you should have at this point. Then you draw your table. I'm going to draw my table here. What I expect to be the outcome when I'm about to fill the table. I'll just put x and I'll put y. So I'm going to divide this. This is what? -2, -1, 0, 1, and 2. Okay, I don't really need all this space. And 2. So these are the values of y, of x. So I will now try to fill in the value of x now. I'm going to fill in the value of x, right? Okay, for x, it will now be, so look at this. So y is equal to x minus 1. Now, students should be very careful when you see questions like this, because your workings is where your marks will lie. Now, so x equal to minus 2, y will be equal to minus 2 minus 1, that is minus 3. So once you get the answer, put it immediately. Don't wait. Some people say, I want to wait till I finish. No, put it immediately. It's better that way. So x is equal to minus 1. Y will be equal to what? Minus 1 minus 1. And that will be what? Minus 2. Now x is equal to 0. Y will be equal to 0 minus 1. And that will be what? Minus 1. This will be what? Minus 2. Now x is equal to 1. And what? Y will be equal to 1 minus 1. And that will be what? 0. Put 0 there. And the last one, x is equal to 2, and that will be y equal to 2 minus 1, and that will be what? 1. So 2 minus 1 will be equal to 1. So this will be equal to what? 1. Are you seeing that? So the tables of value they ask you to prepare is nothing more than this. So that's what they asked you to